Good day, everyone. Today, I would like to introduce Flair, a project focused on a challenge that is becoming increasingly important as machine learning systems grow in scale and complexity. Software engineering has mature infrastructure for managing how the software evolves. However, the evolution of trained machine learning models remains far less structured, reproducible, and collaborative. Flair is an attempt to address that gap. Modern software systems are rarely built by a single individual. Multiple contributors work independently, experiment with new ideas, and continuously improve a shared system. Infrastructure for this collaboration transformed software development from isolated effort into collective progress. And it was Git and GitHub that made all of this possible. Almost all of the technologies we rely upon are built this way. Collaborative AI development is not a future vision. It is already happening today. Large AI systems are developed by teams of researchers working on different aspects of the same model. Multiple experiments run simultaneously. Improvements are continuously evaluated and integrated. The challenge is that these workflows often rely on custom infrastructure, internal tooling, manual coordination, and significant engineering effort. In other words, collaboration exists. What is missing is a standardized and accessible infrastructure layer that makes this collaborative model development easier, more reproducible, and more transparent. As machine learning projects grow, experiments accumulate, and model versions multiply. The file names of these different versions get messier. Eventually, the challenge is no longer producing a model. The challenge becomes understanding how that model evolved over the time. The machine learning ecosystem already has excellent tools. However, these tools primarily focus on training, experimentation, visualization, or deployment. A different challenge remains. How do we manage the evolution of models as multiple contributors improve them over time? We have the training tools, we have the experiment tracking tools, we have the deployment tools, but we still don't have a widely adopted repository system designed specifically around model evolution. Up to this point, we've discussed a gap in machine learning infrastructure. Flair is our attempt to address that gap. At a high level, Flair is a repository platform designed specifically for machine learning models. It consists of two components, which are complementary to each other. The first is Flair CLI, a local CLI which provides version control capabilities for the trained models within the researcher's local environment. The second is FlairHub, a repo manager which provides a collaborative platform where repositories, contributors, model history, and performance information can be managed and explored. Together, these components enable researchers to treat machine learning models not as isolated files, but as evolving assets with traceable history and collaborative workflows. The goal is not to replace the machine learning tools. The goal is to provide the infrastructure layer that helps the researchers understand, manage, and build upon model evolution over time. What would a repository look like if it were designed around model evolution rather than source code files? Unlike traditional repository platforms that primarily focus on files, FlairHub focuses on model evolution. Researchers can immediately understand the state of a project, who contributed to it, and how it has evolved over time. The repository becomes a living record of the model's development journey. One of the largest inefficiencies in the modern AI development is not the lack of data, computing power, or talented researchers. It is the inability to effectively preserve and build upon previous progress. Across universities, hospitals, and research labs, teams frequently work on similar kind of problems. Valuable discoveries are made by them, models improve, training strategies evolve. Yet, much of this knowledge remains isolated inside individual projects and the institutions. When a project ends, a student graduates, or a team moves on, a significant amount of the learning often disappears with them. The next researcher frequently starts from a checkpoint. rather than from accumulating knowledge. As a result, organizations repeatedly invest time and resources solving the problems that had already been solved elsewhere. Therefore, the challenge is not merely creating better models. The challenge is preserving this accumulated progress over time. This is one of the most important capabilities of Flair, the ability to merge the training done by different people on different data into a single model. Imagine two hospitals are working on improving the same diagnostic AI model. Hospital A discovers an improvement that helps the model identify one disease more accurately. Hospital B discovers another improvement that reduces false alarms. Traditionally, these improvements often remain isolated in separate versions of the model. Flair enables those contributions to be tracked, preserved, and when compatible, combined into a shared model evolution pathway. The result is that institutions can collectively improve a model rather than repeatedly starting from scratch or duplicating each other's work. Collaborative model evolution enables progress to accumulate rather than remain isolated. Every successful contribution becomes a foundation for future work. In many ways, Flair aims to bring the same level of collaboration to machine learning that version control brought to software development. If, by the way, we merge our codes has been revolutionized using Git and GitHub, Flair solves a critical challenge in AI. How do we Git merge the actual intelligence of the models trained on completely different datasets? Research is fundamentally an experimental process. New ideas need to be tested, new datasets need to be evaluated, new training strategies need to be explored. However, experimentation often introduces risk. Researchers may spend weeks or months improving a model only to discover that their newly developed training approach reduces the performance or introduces unexpected behavior in their models. So, in many projects, recovering from these situations can be difficult and time consuming. Flair addresses this challenge by preserving the complete evolution history of a model. Every training milestone becomes a recoverable state. So, if a particular training path produces undesirable results, researchers can simply return to a previous stable version. Conceptually, this is similar to how software developers can revert changes when update introduces problems. The difference is that Flair applies this idea to trained machine learning models. The result is that researchers gain the freedom to experiment more aggressively because successful work is never at risk of being permanently lost. In our view, this is not merely a convenience feature. It is an important mechanism for accelerating innovation. When researchers are confident that progress can always be recovered, they become more willing to explore new ideas. Most machine learning tools can tell you if a model improved by showing changes in accuracy or loss. However, they leave a black box when it comes to what actually changed inside the model. Flair fixes this. We combine performance tracking with deep model comparison, linking how the model evolves directly to clear results. With Flair, developers don't just see that a model had gotten better. They can pinpoint exactly which code and which data contributions drove these improvements and which ones did not, and at what point of time. As machine learning models become larger and teams become more collaborative, this visibility isn't something that's just nice to have. It's how the teams save hundreds of development hours. Flair is designed as a two-part ecosystem. The first component is Flair CLI, which is free and open source. Our objective with this is to encourage adoption, experimentation, and community participation without creating barriers to entry. The second component is FlairHub, a repository manager which provides managed repository infrastructure and collaboration services. So, as organizations increasingly rely on collaborative model development, services such as repository hosting, governance, auditability, and institutional collaboration create opportunities for sustainable recurring revenue. Importantly, the project is currently in the MVP stage. Our focus today is not commercialization. Our focus is validating the workflows, refining the platform, and establishing meaningful research collaborations. We believe that adoption and utility should come before monetization. However, the architecture has been intentionally designed so that sustainable revenue opportunities naturally emerge as the ecosystem grows. One of Flair's biggest advantages is its capital efficiency. Unlike AI startups that require expensive GPU clusters and massive cloud budgets for the training of models, Flair operates as a collaboration and repository platform. Our infrastructure requirements are fundamentally lower, meaning our costs grow gradually rather than explosively. In fact, at our current stage, development and maintenance can be comfortably supported without external funding. This architecture gives us the unique freedom to focus entirely on user validation and solving the problem correctly without the immediate pressure of aggressive fundraising. But while our operational costs remain low, our long term commercial potential is massive. As collaborative AI development grows, teams will heavily rely on repository hosting, team collaboration tools, and enterprise governance. These services naturally create predictable recurring revenue. Flair uniquely combines these two rare traits: incredibly low overhead today and massive enterprise scalability tomorrow. One reason we have been able to pursue Flair as an independent project is that the operating costs remain relatively modest during the validation phase. This gives us an unusual advantage. Since the project is not dependent on immediate fundraising for its survival, the primary bottleneck is access to real world collaborators and pilot environments. In our view, validation should come before scaling. Therefore, partnerships with universities, hospitals, and research institutions are significantly more valuable at this stage than financial capital alone. At the current stage of development, the largest challenge is not infrastructure. The largest challenge is ensuring that the platform solves meaningful real world problems. This requires access to researchers, institutions, and practical deployment environments. Feedback from actual users is significantly more valuable than financial investment at this stage. That is why we are prioritizing institutional partnerships and pilot collaborations. We are looking not only for funding, but also for opportunities to validate and refine the platform within real world research environments. Version control transforms software development by enabling collaboration at scale. We believe machine learning is approaching a similar moment. As AI systems become increasingly collaborative, the ability to understand, manage, and combine the model evolution will become a foundational requirement. Flair aims to provide the infrastructure that makes that possible. With this, me, Devashish, one of the founding members of Flair, would be concluding this presentation. Thank you.